Welcome to today's Research Pays Off. I'm now going to hand it over to our speaker, Dr. Fan Yin from NCAT.
Hey, all right. Thanks, Lauren. Good morning, everyone. Thank you for joining today's webinar. Very excited to be, to be here to talk about one of the projects that we recently completed for NRRA. It's titled "The Standardization of Stripping Inflection Point (SIP) Calculation for Hamburg Wheel Tracking Test." My name is Fan Yin. I'm with NCAT. Been doing asphalt research for a little bit over 10 years and has been very excited over the last 10 years working at NCAT. This is one of the topics that I got the opportunity to work with, NRRA, and definitely want to give a shout out to NRRA for sponsoring the work. Before I get started, let me see if I can make this PowerPoint working. There we go. Okay. Yeah, as I mentioned, this is one of the projects that we completed for NRRA and definitely appreciate the sponsorship. And also this project received industry cost share support from 3 industry partners, including Instrotech, PTI, and Traxler. So definitely want to appreciate, their support of this project. We would not be able to, finish what we did as part of these efforts without their, support from the very beginning. And also, I'd like to acknowledge the TAB, the advisory group that we had for this project for guiding us through this, research effort. Those are the group of people that we met at the beginning of the project to set the stage, if you will, to make sure, we're all clear and on the same page about what we try to accomplish and what are the deliverables that we intend to provide as the end of the project. As you can see here, I'm not going to go through the list, one by one, but we got a great collaboration with, state DOTs and also former employee with the Federal Highway Administration. That's really showcased kind of the great effort that NRRA has been doing. It's pulling all those resources and manpower together to really advance, the new technologies and advancements that related to what we do. I mean, this specific case related to the flexible payment team. I got the opportunity to present today as part of the webinar on what we did as this research project, but it's definitely not a one-man show for this effort. I received, great support from the team members listed here. Dr. Chen Chen, who is an assistant research professor at NCAT. He was also the co-PI of this project working with me. In addition to that, we also have the pleasure of working with Dr. Qi Li, who is currently assistant professor at Fisk University. But before that, when he was working on this project with Chen and myself, he was a former Ph.D. student in computer science at Auburn University. And the reason we brought him on board was because, as later I can explain in more details, as part of the project, we developed a software to automate the calculation of stripping inflection point and some other parameter related to the Hamburg wheel tracking test. Chi and I, we are civil engineers. We got excited when we talk about asphalt binders, asphalt mixtures, but we have limited experience working with kind of software development, and that's why we brought Dr. Qi Li on board with us to advance that effort. So definitely want to give a shout out to them. It's a great team collaboration, and we are very pleased with the outcome that we accomplished and also the products that we were able to provide, back to NRRA and also the research community. So a little bit background information on how and why we did the research that I'm presenting today. Many of you, I hope, who joined the call today are familiar with the Hamburg wheel tracking test. It's obviously a very popular lab test for evaluating rutting and the moisture resistance of asphalt mixtures. At the very beginning of this project, we did a survey of state highway agencies in 2024. And I want to take this opportunity to thank the AASHTO Comp for helping us distributing the survey to 50 U.S. state DOTs for, to collect their input related to, the scope of the survey. For the survey, we received responses from 43 state DOTs. Among those agencies, 32 agencies indicated that they use Hamburg wheel tracking test for different purposes. More specifically, there are 18 states indicate that they use a test for mix design approval. In other words, like they are using the test as part of the, mix design process to, make sure like as an asphalt mixture have adequate rutting or like, moisture resistance before they got approval to proceed into the production phase. There are 6 agencies by the time we did the survey reported they are using the test for production acceptance. They either look at the test as a kind of like a go versus no-go type of evaluation, or there are a couple agencies that they use the Hamburg for like a pay factor adjustment. So depending on the test result that were collected on the plant produced mixes, they may be able to provide a bonus or penalties depending on the test result compared to the threshold number they have been using in their specification. 19 agencies indicate that they use the Hamburg well tracking test for forensic analysis. This is something that has been widely reported in our community. And finally, there are 26 agencies indicating using Hamburg for research evaluation. They may have not moving into the phase where they have implemented Hamburg for mix design approval or for production acceptance as part of the BMD framework. But, they use Hamburg on a regular basis to look into like research, related to like new materials and new, mix design procedures, those kind of effort. So, all in all, that means like, there's, great popularity among state highway agencies and our industry using this specific lab test. I mentioned earlier that Hamburg can be used to evaluate both rutting and moisture resistance. So I mean, there's lots of good discussion related to kind of like how Hamburg was developed and evolved, especially in the United States. One thing that I personally have heard lots of good comments or feedback from the DOTs interested in using this test is that because the test is ran with the specimen submerged underwater, it allows the users to really look into kind of like a both rutting evaluation and moisture evaluation of asphalt mixture. So you don't have to run like a two separate tests to capture those, behaviors of mixtures. It's kind of like, use one stone to kill two birds type thing. And that definitely, provide lots of merit in terms from the implementation side. The map I'm showing here are those, 32 agencies that indicated in the survey that they use Hamburg for evaluating asphalt mixture performance. And I'm using like different colors to separate them into 3 different groups. The first group are the ones that are highlighted in green color, and those are the ones that are using Hamburg for pure rutting evaluation. Okay, I mentioned like even though you can use a test for moisture damage evaluation, but those 13 agencies are only using the test for rutting evaluation. And then the second group is really just one state highway agency based on the survey response we collected is Delaware. And Delaware DOT using the Hamburg for moisture resistant. They have a separate rutting test and they have been using based on their historical effort, and they're just using the Hamburg for moisture evaluation. The last group shown on this map are the ones that highlighted in orange, and those are the ones that using the Hamburg for both rutting and moisture resistant. So it goes back to kind of like the early discussion that I provided. Because the test is ran with specimen submerged underwater, it provides that capability. And that's why like those agencies that highlighted in orange color on this map here are really taking advantage of that, benefit provided by the Hamburg well tracking test to look into both rutting and moisture resistance. So, I mean, that hopefully that'll give you a pretty good idea of kind of like, how Hamburg has been used, among the highway agencies for evaluating asphalt mixtures. As part of the survey, we also asked DOTs who use Hamburg for different purposes, what are the test parameters that you look at? As I mentioned earlier on the previous slide, some use it for rutting evaluation, some for moisture, and over 50% of those agencies indicated a combination of both. And this slide really summarized the responses that we received regarding the different test parameters. On top of the list, the most common one is, the traditional rut depth at 30 number passes. that number could vary from like, 5,000 passes to all the way to 20,000 passes, depending on, highway agencies. And that is, very common when we talk to DOTs or the asphalt industry, contractors or testing lab, every time we look at the Hamburg data, this, I was saying like this is the parameter that is always shown on the test results part. It's like, how much rut depth you got after you finish running the test. In addition to that parameter, the next two popular ones are the stripping inflection point as the number of passes to 12.5 millimeter rut depths. The number of passes to 12.5 millimeter rut depths is, really kind of like highly related to the first parameter, like rut depths at number of certain passes. It just give you idea of how many number of passes the mixture is able to tolerate before reaching 12.5 millimeter rutting. Okay, obviously, the higher the number, the better in general for rutting and moisture resistance. But one thing that is related to that parameter that can be tricky or can provide sometimes misleading conclusions is that the rut depth that are collected within the specimen can come from rutting, moisture, or combination of both. And this is where from the asphalt research perspective, we like to dive a little bit deeper into that to really understand what is the root cause of that rut depth. It is really from the permanent deformation of the specimen, or is from of the adhesion failure between the aggregate and asphalt binder, and therefore causing the stripping. So we'll get into that later in the presentation. The parameter that is highly related to the scope of this project is stripping inflection point. As you can see here, like 17 agencies using stripping inflection point. Obviously, the stripping inflection point is a moisture resistant parameter, and it is a parameter, the primary parameter specified in AASHTO T324, which is the gold standard, if you will, for this Hamburg well tracking test in the United States. The stripping inflection point, the definition is fairly straightforward in the AASHTO test standard, but how to calculate those parameters based on the real test data sometimes can be very tricky, and it can be a little bit challenging to handle from the consistency perspective. If we look at the language in AASHTO T324, stripping inflection point is defined as the number of passes where the two straight lines best fitting the creep and the stripping face of the Hamburg rutting curve. And that's really kind of like what this plot is illustrating, on the Hamburg test data. Obviously, like as the number of passes increase, we see like rut depth increases. And at the first part of the curve, the increase is fairly consistent, right? That means like, the slope is almost like very consistent, and we can fit a linear trend line to the first part of the curve. And then as the test continues, and this is where we see like a very sudden, change in the curvature of the curve. And that means like, the deterioration within the asphalt mixtures speed up, right? And the reason for that behavior is really related to the moisture damage of the asphalt mixture or the stripping damage of the asphalt mixture. And then according to the definition in AASHTO T324, in order to calculate SIP, what we need to do is first to define, the creep and the stripping face of the curve. Obviously for the data or the example provided in AASHTO T324, it's very obvious that, over here is probably like the creep face of the curve. And then the later part of the curve that I try to highlight with the highlighter here is the stripping face. And then you just need to like fit two like straight line that can best fit those two faces of the Hamburg curve. And then where those two straight lines intersect, it's defined as stripping inflection point. Conceptually, it's very straightforward. I think it does make sense, right? You have the creep face to start with, and then later in some cases you got a stripping face. What's the cutoff between those two faces, and that's really the stripping inflection point. Even though the definition is very straightforward, AASHTO T324 does not provide very specific instructions on how SIP should be calculated. It does require you to fit two straight lines, but there's no further instructions on how to determine those two straight lines. So if you're the one that get a data in front of you in the on the computer, you probably wonder, it's like, hey, how do I know this is the best fit line for the crib face, and this is the best strip line for the stripping face? I'm sure, like, if we got the same set of data and ask 10 different people to fit those two best lines, we're probably going to get 10 different answers. They're probably going to be reasonably close to each other, but they're not going to be exactly the same. And that's really the subjective nature of the SIP calculation, mainly because there's no detailed or specific instructions on how SIP should be calculated. And that's really kind of like the motivation or the problem statement for this research. As I mentioned, like, sometimes the calculating stripping inflection point can be challenging because in some cases, especially for Hamburg test result with marginal stripping failure, clearly separating the crib face and stripping face is not as straightforward as the example that I showed you earlier. And because of that, there's different manufacturers, different research organizations, and DOTs have developed a different approach based on their experience. But unfortunately, those methods do not always provide the same results. Okay, they can be a little bit different depending on how the calculation was done. All right, give me 1 second. I think my sharing screen function is not working now. Can you still see my PowerPoint?
No, we can't. It did go away.
Okay, all right, let me see what happened.
There we go.
Okay.
There, great.
Okay, all right, sounds good. I apologize, I'm not sure what happened. The only thing I knew was like when I share screen, there was kind of like a red box around my, the edge of my screen, and that was gone. I was like, all right, what happened there? But all right, let's continue. No, I cannot advance slide. Okay. So, I mean, that challenge has been well recognized and documented in historical effort. About like 10 years ago, there was an NCHRP project that was completed by Dr. Louis Muhammad at Louisiana State University. It was a great research that was tried to further standardize the Hamburg testing. And, as part of that research effort, they recognize, the difference in SIP calculation among different methods that has been developed in the past. This is really kind of like a screenshot of some of the data they reported in their final report, highlighting the difference in SIP from different, vendors or the DOT that are using this test. In this case, what they did was, they talked with, 4 different vendors, equipment manufacturer, and 2 state DOTs, identify, the methodology they were using. And then like they applied those different test methodologies to the same set of data. Okay. I mean, there's no difference among the data. It's just one set of data, but the same data was analyzed using different methods. And then they reported the SIP values for each method. As you can see here, I mean, the test results, except for vendor B, not sure what happened to that specific equipment, analysis. All the other 5 vendors provide reasonably consistent numbers. The lowest is a little bit over 9,000 passes, and then the highest is a little bit over 11,000. They're not identical, but they're consistent or, comparable. But then the tricky part is that, if let's assume, this is a mix from a given DOT, and that given DOT has a minimum of 10,000 passes for SIP for, let's just assume for mixed design approval. So now the tricky part, the question comes here is, for the same set of data, depending on different approach that I can apply to the data, I could get results that give me SIP over 10,000, and therefore my mixed design should be good to go, right? Because I passed the DOT threshold number. But there are some cases where like I use the same set of data, but using a different approach, and then my SIP number is going to fall under that 10,000 passes threshold number, and therefore my mixed design will not be accepted. At the end of the day, that's still the same set of data, the same mix design that were submitted for evaluation. But just because the different approaches that has been developed to determine SIP are different, and that could provide misleading and or inconsistent, conclusions or findings moving forward. So that's really kind of like the motivation of this research. That's going to lead us to the objective. There are two objectives that we set forward for this research effort. The first one is to standardize SIP calculation. There's really like not, right or wrong for those methods that have been developed. It's more about what is the one that is most robust or like the one that is least subjective. And, consistency is important. One thing I learned over the years about balanced mix design implementation, specifically on sample preparation, is that consistency is a key, right? If we do not do the things consistently, we're going to have different results. The same thing applies here. For the same set of data, if we do not do the analysis consistently, we could end up providing different results. So that was really the first objective, is to standardize SIP calculation. And then the second objective was to develop a data analysis software. So that would allow like a more, standardized calculation of the approach of the data from different equipment manufacturers. What we want the software to be able to do is to be able to direct, read, and process the raw data without any further manual processing. Basically, if you are the one running the Hamburg after you finish the test, you get the specimen out, drain the water, clean your device, and then you go to the computer, copy the data file into your thumb drive. And then that data file, we want you be able to, upload into the software without doing any further processing, okay? By doing so, we'll be able to avoid any subjective data manipulation or interpretation. In other words, we'll let the software do all the work, and then all you need to do is to copy the data, upload the data, and trust the software to do its calculation, and it will give you a report with all the calculation that is required to give you the number that you want to use for your own, purpose, whether it is for mix design approval, production acceptance, or just for research. That's really kind of like what we want to do for the software. So at the beginning of the project, what we did was what we call like information gathering. We surveyed like state DOTs and different Hamburg equipment manufacturers, at least like on the market in the United States, to summarize existing SIP calculation methods. And based on those efforts, we identified 7 different methods. 4 of those were developed or used by different Hamburg equipment manufacturers, 2 from state DOTs, and 1 from research organization. Okay. And as I mentioned earlier, as part of the motivation, we know like those 7 methods are not identical. In most cases, they are fairly comparable with each other, but there are cases they can provide very different results. And then we did the same thing as what I mentioned earlier for that NCAT project. It's like we collected 3 sets of Hamburg data. 1 without stripping failure, 1 with marginal stripping failure, and 1 with what I would call like a severe stripping failure. So those are kind of like the 3 very different scenarios that we can, run into by running, the Hamburg well tracking test. And then for each set of data, we apply the data to different SIP calculation methods identified from, the survey. And those methods are listed as A, B, C, D, goes all the way to G. What I'm showing here is the first example data. And as you can see here on the left side of this slide, this is really the rod depth curve. And it's very obvious that, this is a data that did not show stripping failure. We got some of the post-compaction phase, and then we got this nice steady increase in the rod depth, which is related to the permanent deformation of the specimen. And in this case, for those of you who have done lots of Hamburg testing, you'll be able to tell us there's no stripping failure, and I would expect like no SIP calculated, okay, for this parameter. And that's basically what, all those 7 methods told us. We ran the data, through each of these methods, and, this table summarized the results. all these methods indicated that for the data that's shown here, there's no stripping, even though like method E and method F, they calculate the stripping inflection point based on the calculation, details or algorithm that was involved. But then because they did not meet a certain stripping, threshold number that defined as part of that method, they reported this set of data as no stripping, and therefore like SIP is not available. Okay. In this case, I feel pretty good about all these methods, right? They're fairly consistent, saying like no stripping, and that's what I expect by just visually looking at the shape of the Hamburg raw depth curve. Now, if we look at the second example, this is where I call like data with marginal stripping failure. So if you look at the shape of the curve, this part is what I would call like the creep face. The slope is fairly consistent. But then at the very end of the test, I think you can tell that, the slope of the curve changed, slightly, right? It shows like a faster deterioration as compared to the first part of the curve. And that's what we believe related to stripping. But it's not something that you just look at the data saying like, oh yeah, it's definitely stripping failure have occurred. You have to, have some experience from, previous effort to be able to make that judgment. And that judgment is what I would call like subjective, unfortunately. And then the same thing, we applied all 7 different methods to this set of data and to calculate SIP. In this case, all the different methods reported an SIP number, and they vary somewhere between like 13,000 passes to almost like a 17,300 passes. So I would say like, they are not significantly different. Considering the variability of the test, but obviously like there are some notable differences among those test results, right? And that is kind of like where, the finding or, interpretation of the result can be misleading because once again, if I, just assume this mix design has, a 15,000 passes as the, approval criteria. In some cases, this mix design would get approved to proceed. But in some cases, it will be a different story. So that's really kind of like, the unfortunate part of the lack of consistency. The last set of data is what I call like a data with a severe stripping failure. If you look at the shape of the curve, obviously like the curvature of the raw depth curve changed significantly somewhere over here. And that's related to kind of like, this part related to the rutting, and then the second part related to the stripping. And, it's in this case, the deterioration was very fast, and it reached about 12.5 millimeter at around maybe like 11,000 to 12,000 passes. All we're saying is like, this is where the set of data that, the mixture experienced stripping failure. And now we did the same thing, applied all 7 different methods to the set of data and reported SIP. And in this case, except for method F, all the others identified SIP, and these numbers vary from like 8,000 to 10,000 passes. Not too bad in terms of from the consistency perspective. But method F, for some reason, it reported SIP number as 8,663, but because of some of the additional parameters or associated parameter not meeting specific criteria used for that method, the overall, reporting for the stripping inflection for that method is that there's no stripping. But, as we just look at the curve, we know that is not correct. And that's, where the method may need some tweaks to make it, more accurate evaluation on the moisture part. So once again, like, this is just some example data that we used to illustrate the issue that we have is that, the methods are fairly reasonably consistent in most cases, but in some cases it can be different. And that's really kind of like the issue that we try to address in this effort. After that, what we did as part of this research effort was to critically review each methodology to identify what are the good things about that method and what are the limitations of that method if there's any, okay? And then based on that critical review effort, we select what we call the most robust method to develop software. Most robust in this case really means like the least subjective. I don't want me as a user to tell the program to say like, hey, I think this SIP is need to be calculated this way or that way based on my eye test, but that's really not the ideal situation because that involves like subjectivity, and we try to avoid that in terms of calculation. We want the methodology to do the calculation on its own without the humans telling them what to do, and that's really kind of like the criteria we use to select the method. Eventually, the method we selected was really referred to as the method G in the final report. Later, I'm going to provide a QR code for those of you who like to get a copy of the report. Basically, what we did in this method is to apply a Franklin model to the rod depth curve. For those of you who are familiar with flow number test or has done some of the flow number testing in the past, you probably recognize the model. I mean, that's exactly the same model that was used in the flow number test to determine the flow number. And that is purely a kind of like a mathematical equation that allow us to fit the rod depth number versus different number of cycles. And then we'll be able to apply additional calculation to calculate SIP. For the interest of time for this presentation, I'm not going to get into details on how the calculation works, but the report does provide step-by-step instruction or discriminations on how to calculate the creep phase, the stripping phase, and therefore the SIP based on those two phases that I just defined. And that's really the method that we recommended moving forward for the software development. After we selected the methodology for calculating SIP, the next decision that we had to make at that time was what are the parameters we want to include in the software? Obviously, like we always want to tie back to AASHTO T324. That's why, like as you can see here on this slide, the first part of the parameter that we look at is what I call like AASHTO parameter. All those are related to the SIP or some other parameter in the AASHTO T324. And we feel like, hey, in order to provide a robust evaluation or comprehensive evaluation of Hamburg, we need to provide all these parameters for those users who are interested in looking into, different parameters rather than just one or two. Another set of parameter we decided to include is what we call like a research parameter. And this is some of the, based on some of the work that has been done at NCAT and also like when I was a graduate student at Texas A&M, to look at the different ways to analyze the Hamburg data. It's still the same set of data, but we try to separate the rod depth curve into two parts. One part related to the rutting and the other part related to moisture. Because we know, from the mix design perspective, it takes different strategies to fix the rutting issue compared to fix the moisture damage issue, right? So I see the need for us to better understand the cause of the distress that observed in the asphalt mixture specimen during. Was there a question or? Okay, all right, I'll continue. From the rutting or the moisture. And then that's really kind of like the alternative parameter that we have been looking into over the last almost 10 years now is, to separate those two that can provide a more accurate evaluation of the rutting resistant and moisture resistant. And then those parameters that we propose as part of those efforts are referred to as stripping number and the corrected rod depths. Once again, we're not saying like we are using those to fully replace, what we currently have in AASHTO T324, but more providing some additional parameters for those who are interested in looking into, in my opinion, a deeper understanding of, the material behavior during Hamburg testing. Among these parameters, I like to make a quick note here. Obviously, like, those parameters are different, but in terms of how they tie to the mixture properties, I would say like creep slope and the corrected rod depth are pure rutting parameters. And then if you look at the stripping slope, SIP, and stripping number, those are the pure moisture parameters. And then all the others that highlight in the kind of like the light green color are the combined parameters. what I mean by that is like it definitely captures both the contribution from routing and the stripping. So just keep that in mind because later I'm going to touch on kind of like sometimes when we try to look into Hamburg data and how that correlates to some other routing test that has been discussed in our industry. Using different parameters can provide different results. And that is where like I think we need to better understand the nature of these parameters so that we can make the most informed decision on how to use them moving forward. After we decided on the parameter and then, the three of us, we got together, we said like, hey, we need to come up with a name for the software. We are engineers. We are pretty nerdy about, looking into the asphalt mixture behavior, especially for me and Chen Chen. But for Dr. T. Lee, he's more, excited about, coding. But none of us are kind of like a marketing person, right? And we don't know how to come up with a fancy or catchy name. And what we end up doing was to turn to ChatGPT for help. We give a little bit pump about, hey, what we're looking for based on, as an anticipated function of the software. And then we say like, hey, help us out, give us a good name for this software. And then it gives us a bunch of options. And then the one we like the most is Hamburg Expert. And I don't know whether or not it's the best one, but, at least that's the one that we like it the most. So how, I guess just for your information, some of you may wonder, like, how did you come up with the name? It was really ChatGPT. So thanks, ChatGPT, for that. And then we started working into the software, especially with Dr. T. Lee's help. All the data analysis was conducted in accordance with AASHTO T324. I tried to be consistent with AASHTO standard. The software, we decided to make it compatible with 4 data files. Insurtech, PTI, and Troxler. They participate in the project as our industry collaborators, and each of them, they provided us with an example data file that allowed us to develop the program so that, to enable that, data file, uploading, analysis, processing features. So I definitely want to give them a shout out for that effort. And then we recognize there are some other equipment manufacturers who are available on the market, but for different reasons, they decided not to participate in this project. So we don't have the authorization to use their data files to develop the program. Instead, we developed an Excel template that allow users to kind of like manually copy and paste data from, those equipment data files into this template. And then you can use the software to process data following the same calculation or the same SIP method that I mentioned earlier. So provide a little bit more flexibility across a wide range of different equipment manufacturers. And then we developed the software, we put together a user manual, and then we went through the alpha testing within NCAT, using over 100 data files that have been collected from our previous, projects. Some are related to the test track work, some are related to the DOT or the industry work to kind of like fine tune or troubleshoot the program. After we did finish the internal alpha testing, we proceeded into the next phase, which is, beta testing. As part of the DOT survey that I mentioned earlier, there were 25 agencies expressed interested in helping us out with the beta testing. So we sent an invitation to all those 25 agencies and also AASHTO T324 task force to engage whether or not they would be interested in participating, try to, play with the software to see, what are the things they like, what are the things that can be improved. And then among those 25 agencies, 12 agencies decided to join the effort to, be part of this collaboration. And we very much appreciate their effort, helping us out with the software beta testing. And those are the agencies highlighted on this map here. After their trial and errors, we received feedback from 7 agencies. Overall, this feedback was very positive. They identified a few areas based on their experience, saying like, hey, if you could change the feature of, here or there, it would be better. And then, we took those comments, we consolidated, and then, make the revisions necessary to address them into the next phase of the program. And then after that, I mean, that brings us to kind of like really the end part of the project is that we have the software ready to go. And when we submitted the project to NRRA, we made the software available to the public. So whoever interested in using the software, you can access it free of charge. And that's really the beauty of this, program. I do want to spend a couple minutes to do kind of like a live demonstration of how the software works for those of you who have not get a chance to look into it. And we'll come back to this presentation right after that. So let me come back here. I assume y'all can still see my screen. Is that correct?
Yes, we can. We can see the web page now.
Okay. All right. Sounds good. Thank you. So this is really the program. I'm gonna kind of like walk you through on top of the sections. It's a web-based program because it's much more flexible. So everyone can access the program from your computer, from your iPad. So you don't have to, install this program on your local computer. And then sometimes like a software update can be can be problematic for those approach. And that's why we decided to do the web, application. There are 4 sections, home, upload files, analysis result, and about us. So right now we are on the home page. There's really not much, functions on this page. It's mainly intended to provide an overview of all the data files available on the server, if you will. So, right now we probably have over like, 250 files that have been used by different, users. I don't know where they are because we are now tracking the history of that. But it does provide you a good idea of, what are the data file format. We have, Troxler, Instratec, and PTI, and, you can, sort the file format, and also like when the data was submitted, and also when the data was analyzed. It's more about give you an inventory of what's available on the database. And then if we move to the second part, which is what we call like upload file. And this is where like you can upload your data file that you copy from your, Hamburg equipment in the lab. Okay. And then, there's a drop-down menu that give you different options, custom, that really means the Excel template that I mentioned. And then you have Instratec, PTI, or Troxler. If you have an Instratec device in your lab, then obviously you just select that option, vice versa for the others. For example, for this demonstration, let's just pick Troxler as example. And then after you select the device, you can click here, choose file, and then you just need to navigate to the local file where you save the file, you save the data, from the device. And then I'm just gonna use an example file for illustration purpose. I'll just select this file, and then now the file name is shown here. And then you click upload, and it typically take about a couple of seconds, and then it shows the file uploaded successfully. And then over here, this is really the file. This is really the file that I just uploaded. The data created is today. And then you just need to click on this cloud, icon to process the data. Okay, you click on that, and then you got, a note indicating your file has been processed. Then you go to the third section of this web page. It's called analysis results. Okay, there's lots of data files here, but you can sort them out based on the data analyzed. If I, based on the data analyzed here, the latest one is the one that I just did. Okay, Troxler example. And then the data has already been processed. All you need to do is click on this icon, kind of like a bar chart, and then that will show you all the data that you need. If I do that, this is what you got on the analysis results parts. There are two sections. One is kind of like a plot. Obviously, Troxler, their preference is to report the left data, the data from the left wheel and the right wheel together. So that's why like we provide those arrows to navigate between, the two wheels, left and right, depending on how you want to look at it. Another thing I want to mention really quick here is that this plot is interactive because there's different parameters are indicated here. And if you're not interested in a specific parameter, you can just check them out. For example, if I'm interested in stripping number, I'll just show it here. But if I'm not interested in that, I can just cross it out, only showing whatever parameter I'm interested. Okay. For example, like I'm not interested in the fitted, rut depths, and I'm not interested in the stripping inflection point. All I'm showing is the measured rut depth. Okay. But if I'm interested in looking at the creep slope, stripping slope, and SIP, and that's really like you can, click on the legends behind the figure to show whatever you want to show. For your report later, I can explain. And then if you scroll down, the second part of this, report is kind of like a table format test results. It provides the AASHTO test parameters that I mentioned, and also the additional research parameters. In this case, it's providing the summary for left and the right, and then we reported the average and the absolute difference between the two. But if you're running different mixtures, from the left well versus the right well, then you don't have to look at the average and absolute difference. You just need to look at those individual column data. There's lots of parameters. All those in the first part are in the AASHTO T324. And then the new parameters, all the research parameters, are the one that I mentioned earlier. And then, if you're interested in get a better understanding of those parameters, or you can click on the link. That will take you to the reference that will provide more detailed information on how those parameters were developed. So, and then you can export the data to PDF or to Excel. If I just click on export to PDF, and that will give you a nice printout of all the data file of all the data that I showed you on the web page, and with the plots included. And then you can print it out, submit it as part of your mix design package or whatever you're doing. Or you can export to Excel. That's going to give you the Excel file with the same set of data. And then you can, copy the data into kind of like a master database for, if you're doing BMD benchmarking or some other efforts, that will give you that option. So that's really how the software works. It's fairly straightforward. And then the last section of the program is called About Us. This is where like you can find more detailed information about, the project, where the software was developed, and also the user manual and some example data files, and also our contact information for those of you who run into any questions. So, all right. So, some of you may have already got a chance to look into it. And, for those who have not, if you're interested in playing with the Hamburg software, which is, free, we do require registration, mainly because we anticipate in the futures there may be some software updates. So we just want to make sure everyone is informed about using the most latest version. So, once again, it's a free program. We're not charging anything. It's more about making sure like you are using the right version moving forward. So for those of you who are interested, just, fill out the registration form, and then we'll send you the login information, and also with a user manual, and also you'll be in our database to be communicated about future updates. And also for those of you who want to get more detailed information about the final report, which have a whole lot of detailed information than what I presented today, this is the QR code, or you can just go to the mndot website, go into the NRRA flexible team section, find the project, and then, that will take you to, the final report that was published a couple months ago. So. The last slide I have is that I mentioned earlier that, Hamburg is one of the most popular routing tests used in our industry. And more recently, there has been lots of good discussions on using, the ideal RT test or the high temperature IDT test as kind of like a quick surrogate test for routing as part of the BMD efforts, especially on the production side. So the question that, we have been discussed quite a bit at NCAT is, does ideal RT or high temperature IDT correlate with Hamburg for routing evaluation? And we, did our, analysis using some of the data that we collected over the last several years. not only from the NCAT test track, but also like several DOT that we got the chance to collaborate over the last several years. And then we found some interesting conclusions on that. And this is an article that we published in the latest, asphalt technology news. There's lots of good information in that article. For those of you who have not received subscription, we highly recommend you do so. Just be informed about what's going on at NCAT from our research effort, not only just this research topic. So I'm not gonna steal the thunder from what we provided in the article, but really, the simple answer to that question is that it depends. Okay, but depends on what. That's really the article gonna provide much more detailed information. Long story short, for this presentation, it depends on the nature of the parameters. If you are using pure routing parameters, then the correlation is there. Okay. But if you are using a parameter that combine routing and moisture evaluation of the asphalt mixtures, then the correlation in most cases is not going to be good enough, because when you look at ideal RT and high temperature IDT, those are pure routing tests. But you are using combined parameter from Hamburg, so you're not doing apple to apple comparison. And that's really the confounding factor from the stripping behavior in the asphalt mixture that throws the correlation off. So once again, for those of you who are interested in the topic, please check out this article, and I'll be, glad to talk to you with more detailed information, at a later time. So with that, thank you very much for your time and attention. Definitely appreciate NRRA for this opportunity to do the research and also participate in this webinar to share what we did. And I'll turn back to Lauren, and we'll be happy to answer any question that may be in the chat box or among folks who participate today.
Yeah, the biggest question I was gonna have you answer first was about how to get credentials, but you did have a slide up for that. So hopefully we can include that on the project page as well, or the some of the other information about this webinar. We do have a couple projects. Kyle has had his hand up for quite a while, so I'd like to get to his question.
Yep.
Kyle, are you there?
I am, and I don't know why my hand is up.
Oh, okay.
I'm sorry.
Right.
I'm sorry about that.
No worries,
good. It can be an easy bump.
Yeah, thank you.
Yeah. Okay, so Ia, we can take your question, then I'll go through questions in the chat.
Thank you, Lauren. Thank you, Fan. It was excellent presentation and excellent product. Thank you for sharing this with us. I have one question. In your plots, when if you got your today one of the plots, any of them, you said that you wanted this software to be as less subjective as possible. But in any of those plots, you can see at least three phases: that early compaction, permanent deformation, and then creep, and then the stripping phase, right? So someone still has to decide how much of that data is going to be used for Franken model and how much of the stripping. How did you go through that? And
yeah, that's a good question. Yeah, I appreciate you bring this up. One thing I should have clarified in the presentation is that in order to calculate SIP, we want the software to be least subjective, but we still need, in order to make the best use of the Hamburg and the data analysis, state DOT still need to figure out, what is considered the true SIP, right? I mean, that's something like, for those of you who have done SIP stripping Hamburg testing before, you recognize sometimes you can get false positive response, right? When you look at the curve, you may indicate stripping, but when you look at the specimen, not the case. And I don't think that's something that can be addressed from the data analysis part, right? You got the data is data, and there's not much we can do on that. I think the better way to address that issue is more about, more strategically select the test temperature that can avoid those false positive. So what we try to do as part of this effort is for the SIP calculation to be least subjective, but still like how to interpret those SIP numbers and to tie it to the field correlation. And that's something that, will require, what I would call like a validation, through a separate effort. I hope I answered the question.
Yes, it does. Maybe related to that, I see a lot of confusion when people say SIP is telling me something about my stripping, but it's not really. It's telling you when that stripping phase is initiating. So
yeah.
The most important is the slope of the stripping. How fast is your material deteriorating? So why not start from the backward and then go to strip instead of coming from?
Yeah.
Any thought on that?
Yeah, I agree with you. Actually, like, one of the references that I provided, that was like from 2014, we discussed that limitation is that it's not, I think when stripping occurs matters, but also like when stripping occurs, how fast or how slow the material deteriorates also matters in terms of the moisture damage evaluation. And that's why in that, research effort and the TRB paper we published, we propose a additional parameter to capture that deterioration rate, if you will. And I think that can provide good information to supplement, either the stripping inflection point or the stripping number, because they talk about different things. When stripping occurs and how fast the material deteriorates after stripping occurs. So 100% agree with that.
Thank you very much, Fan. Great work.
Thanks, Eva.
All right, and then we do have a couple of questions from Cheng here. Did any of the state agencies mention why they decided not to use the Hamburg stripping criteria, such as SIP or LCSN? Has there been research correlating the HWTT stripping criteria to TESR stripping?
Yeah, that's a good question, Chen. Wisconsin DOT definitely has been using stripping number and corrected rod depths. And that's something just because NCAT, we have great collaboration with Wisconsin DOT, and through the BMD benchmarking effort, we kind of like presented the benefit of using those compared to the traditional ones. And, they like it. They have been doing it. For some other DOTs, over the years, I have also been talking to them about it. But I think, implementation of anything new takes time. I think most of the DOT connection that I have talked to about these, they indicate the interest of doing it. But the challenge is that all their historical data is based on those traditional parameters, okay? And they don't want to kind of like, just get rid of those efforts. It's more about they want to collect data to make sure like they are comfortable with those new parameters, and hopefully moving forward, they will be able to adopt, those parameters, which I believe, provide a better evaluation of the mixture behavior. So I think it's more on the implementation, timeline and schedule wise. So in terms of correlating Hamburg and TSR, I think there has been a couple of work that I'm aware that tried to look into it. If I remember correctly, the correlation between the two tests are not promising. And that's really not surprising, to be honest, because those two tests are different in terms of how the moisture conditioning mechanism goes, right? When we talk about TSR, we do like a freeze-thaw saturation, right? But when we do Hamburg, it's a totally different, mechanism. We, submerge the specimen underwater, we apply wheel loading, and then we try to introduce like the pore pressure, go inside and outside the specimen over time. And because of that difference in terms of mechanism, the result can be different. So, once again, based on other people's work, the correlation is not very, promising. And I think the reason is just what I just mentioned. So.
Great. Then his other question is, do you know whether or when the equipment manufacturers will update their programs to incorporate the HWTT expert analysis?
I know like Instratech has updated their program to incorporate the recommended SIP calculation that we recommended out of these research projects. I don't know like whether or not that version has been pushed out to the devices that are already at DOT lab or contractor lab. I'm sure like they have a plan to do it, but they already at least within their headquarters, they already made that effort. I'm not sure about the timeline for the other, equipment manufacturers. They have been informed about what we did in these projects, and I would not be surprised if those manufacturers would go back to update their program to be able to incorporate the SIP calculation that we recommended in this effort. So.
All right, and then Aaron has a question. Well, he first mentions great presentation and excellent research. Then his question is, once data is uploaded, how is it stored and who can access the file, including administrators? And you may have covered this after he asked this question. I can see DOTs being concerned about security in an online app. Hamburg data is likely low sensitivity, but have you considered data storage and access controls?
Yeah, that's a great comment. That's one of the questions that we discussed a lot with our software developer. From his perspective, he want, the software to be perfect. That means like include access controls and the user management. But unfortunately, given, the schedule and the budget constraint, we were not able to accommodate that in the current phase. So right now, the program is basically just a tool. You use it to analyze data. If you are concerned about your data being accessible to other people, then you just need to delete the data after you analyze the results. It's like I said, at this point, everyone shares the same login information. But moving forward, we'll be happy to work with state DOTs who are interested in implementing this software for their own like internal purposes. We can create a kind of like sister version, if you will, for mndot, for example, and then they will be able to manage the data access and also the data storage, so that it will be better off from the data security perspective. But that feature is in the future, and we don't have that functionality at this stage. But we do anticipate. We'll be interested in working with state DOT or contractor, whoever interested in integrating that feature moving forward. So.
All right, well, that was our last question. And so we are a couple minutes over time. So I'll just wrap us up here. But Fan, thank you for your time, and thanks for everybody sticking with us. And we hope you have a safe holiday and Happy New Year.
Okay, all right, sounds good. Happy holidays, everyone.
Yeah, see you in 2026.
Yeah, absolutely. Bye.
Thanks.
Thanks, Lauren.
Yeah.